Good morning, everybody. And in this video, we are gonna talk about how we created our own internal distributed scraping system and our success story. Today, I'm very happy to say we essentially scrape more than 8,000 jobs, nearly more than 8,000 jobs a month, more than 96,000 jobs annually. And in a given day, we are running close to more than 280 to 300 concurrent jobs they are running together. And for each scrape, we literally pay about money in cents. So how we develop this system, this is our success story. So let's get started. So here is our growth. Basically, the reason for starting this project was, initially we were, outsourcing, scraping, and we found a need to develop a system that we can expand upon, right? And we wanted to scale as well. These external firms, of course, would charge you a lot more, and hence we wanted to make our own internal system, right? So this graph basically shows the growth. We started off the development in the year 2022. I still remember I was given a problem statement. We started off in Jan 2022. Nearly in 4 to 5 months, I guess we did a lot of POC, and at the end, we got a POC with which I'm going to show you the architecture shortly. But this is sort of the growth where we are. So these are total number of jobs running every single day in concurrent. So if you clearly see the trend, today we are almost running 288 jobs every single day. So if you talk about jobs, basically in terms of yearly jobs, right? How many jobs are running in a year? So if you see today, just in the month of December 2022, we close to about 8,000 jobs, right? Running in a month. So close to about 96 to 100,000 jobs easily. And we are the month of January is still running, but I'm sure it's going to surpass the number 8,000 jobs. If you observe the month over month growth on an average, it's growing about 100%, right? Total number of jobs that have been added. We developed a system that is scalable, robust, error handling, and we pay 30 cents per scrape at this point. The entire architecture is on my LinkedIn post, and it's again very popular. Again, so let me just go over some of the highlights. So here you can see this is the total number of connections on the database at a given time, right? So the database is essentially used for maintaining metadata. So when a job starts, we insert a new process ID. The process can have several tasks, and if any task failed, which is nothing but a function, we mark that task as failed and the process has failed. So basically, on a high level, you could do process monitoring: how many jobs ran, how many jobs failed, how many jobs are in progress, etc. So that's the process monitoring over here. The system was made in a way that it's much more flexible. It can scale up pretty easily. The user can set up jobs. They use essentially an API, right, to set up jobs through an API gateway and a Lambda. So that part can also scale up. Once the user set up a jobs, so the metadata about the job, for example, what libraries they want to use, okay, then basically when do they want to schedule it, right? How much CPU do they need? How much RAM do they need? What sort of compute power they need, right? So they set up all that metadata over here. Now, depending upon that, what happens is as soon as the metadata is inserted, we also basically create a rule in EventBridge and a cron expression, right? So the cron job will fire that, the cron will fire up a Lambda function and will pass on the metadata. The Lambda will essentially pull the metadata from SQL Server and essentially pass it on to AWS Batch. AWS Batch will here prepare the container, basically will install all the dependencies, all the compute power needed, etc., etc. And the templates will be essentially pulled from S3. So again, these are generalized code templates that it would pull at runtime into the batch environment. Once that is done, it would execute the business logic and then, of course, keep updating the metadata in the database. So here you can see some of the example, the RESTful API you can use. We have a Swagger UI. You can pass in, for example, batch, state, right? So all that is done. And here you can see all the cron expression or rules, I would call, right? each rule fires up a Lambda function, and here you can see how we show the metadata. Here is just a glimpse of it. So you have the job name, job description, the cron, S3 folder path where you would store the log files, right? A secret name, which means if any job has a secret, it will store the secret in AWS Secret Manager. Then you also have the resource on the right hand side, which means you can tell what resource ID to use, right? So here you can see each job when it runs creates a process. A process has a start date, an end date, has a job type, has a status. Each process can have several tasks, right? You can monitor that. Excuse me. You can choose various Python module that you want to use for a job, right? So it's pretty straightforward, pretty generalized, right? You can choose various resource objects. So basically, how much RAM do you need? How much CPU do you need? What sort of power do you need? So all the combination is in there in the table. So you simply select what sort of compute power you need. Currently we use a SQL Server, but in the future we plan to migrate off to DynamoDB. Again, as you can see, it's truly working at a relatively massive scale, right? So here you can see. So the future 2.0 plan would be having multiple job queues and multiple job environments, AWS batch, right? And then depending upon certain rules that we define, it would route the job either to job queue 1 or job queue 2 again. And for the metadata, since we were using SQL Server, we would replace that component by DynamoDB. So that way we don't have to worry about scaling, pricing, and all that stuff. So again, we have also laid out some of the steps here for DynamoDB. So you guys can check this out. But again, what I wanna basically say is, this system today, I'm very proud of. Works at a really massive scale, and I'm so proud that I was part of this and we designed it, right? So very happy about this. We have an entire article as well. We made videos as well. So this is our success story, right? So internally we run a lot of jobs. We bring a lot of data from a lot of external sites. We have a lot of streaming solution as well. We bring them into a data lake. We have transactional data lake, right? So we can perform update, insert, update, delete, everything. And as the volume grows, we pay more, less and less because of S3, right? We have lifecycle policy. We archive older jobs into Glacier, right? So that is our story. And yeah, I'll leave the article in the description. So if needed, you guys can check that out. And yeah, let me know if you guys have any question. But this is our success story, how we scrape more than 100,000 jobs annually, 8,000 jobs a month, 280 jobs at a given day are running in concurrent parallel. And we never ever had any issues on scaling or any sort of stuff. We were able to scale basically with cloud. Thank you so much, and I'll see you in the next video.